My name is Laura Ząbek, and I am PhD student at the AGH University in field of material engineering. And I will show you the presentation about the application of 3D printing in space exploration. But first, we can start about the history of 3D printing. Then I will discuss the selected 3D printing technologies and their potential in the space exploration. And finally, I will move to the examples of this of the use of 3D printing in space exploration. I think not everyone realizes when the history of the 3D printing began. Everything began in 1971 when the Pierre Siraut, I think, published the theoretical work which started production of products of any shapes by combining powdered materials with the help of energy cells. The man who invited, who is the father of 3D printing, is Charles Hull, who filed the patent application of his printer in 1984. The patent was officially granted in 1986, and in the same year, he founded the 3D printing company, 3D System. And in the same year, the STL file format was developed, and which used a G-code file, which are read by 3D printers. This history might look very different today, if not for unfortunate considerers, because less than 3 weeks before Hull, his patent filed a team of French scientists, but this project has shown as no sign of commercial success. And as the result, the application, the title of father of the 3D printing went to the American Charles Hull. In 1988, Carl Deckard, the students at the University of Texas, licensed selective laser sintering, SLS, technology. It's another type of 3D printing that used a laser to sinter powdered materials into solid structure. And shortly after, in 1989, Scott Crump patented focused fused deposition modeling, FDM, which is also known as fused filament fabrication. And the first use of the name of 3D printing was in 1993 by MIT researchers, because later it's named additive manufacturing. Okay, I will choose several technologies, which I will briefly describe on the next slides. It's stereolithography, the first technology of 3D printing, FDM, SLS, DMLS, and DED. Let's start from stereolithography. It's the oldest patented 3D printing technology by Charles Hall, and the most common design 3D printing process. And it's become very popular for its ability to produce high accuracy, isotropic, and end-use parts. The SLA printers produce parts with a range of advantages: materials properties, superior surface finish, and fine features. At the beginning, the working platform is placed in the tank filled with liquid photopolymer or liquid resin at a certain distance of the layer. The height of the one layer of this materials. Next stage, the laser beam, which is focused on the previously determined path using the set special mirrors, hardness the layer of materials. When the entire cross section was scanning, printed, the platform went down by the height of the layer, and the recorder applies another layer of resin to the surface, and it's printed layer by layer. Currently, it's commonly used the reverse SLA methods. The main change here is the direction of printing, the elements, and the movement of the table. And in this version of SLA technology, we do not need the support structure. You can see it at the picture and scheme at this slide. Okay, let's go to the FDM, fused deposition modeling. Parts are built by deposition the layers of melted thermoplastic created the patent of the FDM is to the Stratasys company, and due to huge interest in this technology and the possibility of building the own devices based of this technology, was introduced the new alternative name, fused filament fabrication, because the fused deposition modeling was patented. The technology was initially used to build relatively cheap prototypes and demonstration models, but currently is used to produce high-quality functional prototypes and conceptual models from a wide range of thermoplastic materials. FDM technology is now the most used of our additive manufacturing methods in the world. And in this technology, we need a support structure, as is shown at the picture and the slides. DSLS technology is selective laser sintering is one of the basic rapid prototyping methods belongs to the group of powdered bed technologies. This characteristic feature is selective binding of the layer of the powder. The laser used in this method sinter particles of the powder thermoplastic polymers and combining it into layers. This technology is widely used in prototyping and the small-scale production of functional plastic parts with good mechanical properties. And in this technology, we don't need the support structure. The next technology, DMLS, direct metal laser sintering, it's technology which belongs to the same group of powder bed technologies, but it uses the metal powder. Commonly terms that used for this process is 3D metal printing. In this technology, we use a laser to scan the contour of a given layer from material and melt connecting metal powder particles. In this technology, we need the support structure, and in this technology we can make ready-to-use parts from a very wide kind of metal. For example, steel, nickel, titanium, and the last technology I want to introduce is direct energy deposition. It's an additive manufacturing technology based on direct selective creation of a material layers. The characteristic feature in this, and the difference from the last technology is feeding the materials directly into the molten metal pool. It can be carried to use various energy sources, including the laser or electron beam. And the material is most often fed in the form of the welding rod. This technology allows us to produce elements with high mechanical properties, and the construction, to make the existing elements, make another layers to the existing elements, and also the regeneration of elements that cannot be regenerated using the other methods. Let's go to the potential of the using 3D printing in the space. 3D printing in space, it's experimental technology, but it has potential to revolutionize space exploration. It can allowing the astronauts to produce parts, tools, key components, and building the materials on demand. It's also a great interest to companies looking to create manufacturing facilities in the space that could use the zero gravity and vacuum in space to research and produce things that cannot be made on Earth. Now the examples of 3D printing application in the space exploration that it will be from the last few years. For example, the printing spacecraft parts. The SpaceX used 3D printing to produce parts for example, Falcon 9, a Dragon, and Starship spacecraft. That includes engine bays, nozzles, heat sheds, and various spacecraft docking. And also in March last year, the Relativity Space made the rocket which have 85% of 85% parts of this is which was made in 3D printing technology. And in March, this rocket was launched. The main goal of this test was to check that the Terran 1, you can see this rocket on the slides, that she can survive the aerodynamic forces that act in the rocket during the launch. This rocket, after about 80 seconds of flights at the altitude of almost 16 kilometers above the Atlantic Ocean, the rocket reached the point of maximum aerodynamic pressure, and it flew through this unscattered, and passing the key objective of this test mission. The next application was the printers of orbits made in space. Made in Space was found in 2010, and its name is not accidental. It's produced 3D printers that are adapted to create three-dimensional objects in a state of weightlessness. And in 2014, the first of such device we go to the space. The 3D printer called 0G was sent to the International Space Station, and the experiment conducted proved that it's possible to use this printer to create tools and various elements in zero gravity. And I think the most interesting thing is metal printing, which at the beginning of the last year was sent to the International Space Station. It's made by the Airbus company. commissioned by the European Space Agency. In the August last year, the first printing elements was complete, and the product of these experiments, along with 3 more printing, will be sent back to the Earth for quality analysis, because on the Earth, on the and this, I think the same technology printer will be printing the same geometry of elements, and with in which the quality analysis of both of this. These samples we sent to the ESTED's facility in the Netherlands and to the Technical University of Denmark. The result of this experiment could be crucial for future manned mission, because with the distance, for example, in the case of the mission to Mars, the production and replacement of faulty parts could be very problematic. But with a fully functional metal printer, 3D printer, the crew will be able to replace damaged parts during the flight. Okay, thank you for your attention. That's all.
Thank you, Laura. And if someone has a question, so feel free to ask. I like the last part about that metal printer. I didn't know there is something like that.
Yeah,
and
it's something new, and I think it's very interesting.
Yeah, because for sure for space mission we need something maybe more. Oh, okay, Krzysztof.
Okay, thank you very much for the presentation. Yeah, that the last part was actually very interesting and new for me too. But I have quite a generic question to you, Laura. Imagine that you are a decision maker and you have to decide that something has to be printed in space, not necessarily on the space station. It can be like robotic mission or something like that. What would you propose to print in space? I mean, in the orbit. That's the area.
Yeah, I don't know if I clearly understand the question. You say about the things that you can make.
Yes, yes. Some example. We are here. In the last case, these were bolts. You mentioned that somebody printed rocket parts, but that was on the ground. But if you go to space and have to build something, and you could propose, let's print that component. So what would you propose?
I think the main is the possibility to think to make the object that used in which can be failure at the space mission. I think that's.
Okay, that was kind of a tricky question because this is something that we should think now. I think.
Yeah.
because that will define what kind of technology we could use in space and what approach to choose. Yeah, so for example, if somebody wants to have very small parts like those bolts, the question would be, then the next question would be, what material to use for that, what technology, and that's why I'm asking about the ideas that we should consider now. So, but thank you for your answer.
Thank you for the question. And Powder, I can see you are raising your
yes.
hand.
If I may, I wanted to answer also to a question that you, Krzysztof, raised. I think like we need, for example, different kind of like small parts that would get easily broken in space, because of course ISS is full of, let's face it, a lot of broken things because of the deliveries delays, and deliveries you can't get everything on time. So I think different parts that are needed right now, or for example, if something gets broken, like different screws or maybe patches for the devices that are actually the most important on the space mission or on the ISS.
Yeah, and it's good to think now what it should be, what could we print. But Krzysztof, I can see you unmuted yourself. So
yeah, but you also have to consider another thing, because you know, if you want to print something that it's weighing like 1 kilogram, you have to bring to the station 1 kilogram of material, some spare material, and the printer, which will, you know, take like 10 kilograms. And why not to send directly those bolts made on Earth, which will be weighing just 1 kilogram?
But I think when you have the materials, for example, the powder of the metal, we can make, for example, at the ISS, everything we need. And when we bring something from Earth, we bring some something which, for example, we can need something else that we bring from the Earth, and when you have materials, for example, the spider, we can do it. We just need the CAD project. That's all.
There's also a thing that we're trying to use space regolith as a material for 3D printing, and from what I know, it's already in the process of experimentation. So there is a high possibility that in the future we'll be using space regolith to 3D print parts, and we won't need to launch the metal powder or other powders to the space to be able to print.
okay, and Zuzanna?
Okay, so I've got a question. Is it possible to change already printed parts into the powder again? Because if we have some powder in space, we can use some parts, and when the parts are already useless, we can reuse the powder that was used for printing these parts, and then print something other, and then the printer would make more sense if we could you know, change the useless parts into some new, more useful parts.
now the change the thing in the powder in the space, it's not possible because it's need the optimization device. But I think it can be a good thing to thinking about how to do it. But now it's not possible.
Okay, and how about the strength of the metal that is printed? Is it strong or not?
I don't know.
Well, in case of applications on Earth, it is said that the printed metals have the same properties as cast materials, but the space conditions might be different, so difficult to say. That's one thing. Second thing is that the metal, after printing, should go through the special process called HEAP, heat and pressure, which is quite difficult to do in space. But maybe it's not necessary because the loads are not that high as on Earth. But, it really depends on application.
I really liked that idea of Susanna to like recycle that material, and it sounded like from video game or something where we can craft things and okay. So do we have any questions? Any more questions? I don't see any hands, so probably we can finish our meeting. Thank you, Laura, again for presentation.
Thank you very much for coming.
And thank you all for being here. And that was the last meeting space webinar in this season. But there will be more, so more info there will be available at website of Space Technology Center. And thank you all for your attendance.